Hello everyone. So it's time to talk about lesson 43. So on lesson 42 we see exponential functions. So today and in this lesson we will cover logarithmic function, which is they are super similar. So first part of this lesson we are going to learn how to convert them each other. Let's say if we have this logarithmic, I want to go with this way. Logarithmic base a x equals y. And this is how we convert to exponential form. So x equals, this one you can always leave it over here, and log base a is going to be always base. It's going to be base over here, and this one going to be my exponent, everyone. Right? That's how we convert each other. We're gonna convert logarithmic to exponential, and then we're gonna convert exponential to logarithmic. That's the formula of it. That's the rule of it. Okay. But I want to mention one more time, this is called base A, and it's going to be always base, as you see here. Whatever you have over here is going to go to top. This x is still there. That's how we convert them. And here there are so many examples over here. As you see, logarithmic base 2, 8 equals 3. So as you see, like this is base, this is my exponent, equals 8. So here, logarithmic base 1/2, 16 equals -4. Still base 1/2. This one is exponent equals L. You can have a look at this one, but I want to show you a few examples. Let's say on this one, logarithmic base 2, 3 equals 8. So to convert to exponential, still base, right? It's going to be my base. Oops, there's something wrong here, my bad. So let me change the example over here. Let's say we got logarithmic 2 base 2 4 equals 2. Again, I'm going to take this 2 to the power 2. It's going to be equal to 4. And you can see that this makes sense. 2 squared is 4, or 4 equals 4. It's going to make sense. So you can double check with that as well. So on this one, it's going to be logarithmic base 3, 27 equals 3. Again, take this, that's my base. That's going to be my exponent equals 27. And on this one, logarithmic base 10, 100 equals 2. And I'm going to take this 10, that's my base still, to the power 2 equals to 100. And that's how we convert exponential. And make sure stop the video and try those, everyone. And even if we have a complex example, like we do the same thing, we do change nothing. Logarithmic base 3, 1/9 equals -3. Again, my base, still base. Exponent should be this one, -2 equals to 1/9. And that's it, like convert to exponential form and leave it like this. And here, same thing, logarithmic base 10, just take your base 10, exponent should be -3 equals to 1/1000. Okay. So by using those, we're gonna solve some questions right now. Logarithmic base 3, 9 equals x minus 3, and solve for x, what x is. So I'm gonna do the same thing basically. I'm not going to do something new. I'm going to do this. Convert the exponential first. 3 to the power x minus 3 equals to 9. And then I gotta try to write them in the same basis. So since we have 9, which is 3 squared, I can write 3 squared there. So as you see, same basis, 3 and 3. If we have same basis, exponent should be same as well. So x minus 3 should be equal to 2. So if I do plus 3, so we should get x equals 5. But that's my answer. Okay? Like that's why I showed those previous examples. Like we're gonna solve these kinds of questions, but in order to solve them, first we should be able to convert easily. Let's say on this example, to find x, like same thing. First, convert to exponential first, and then let's solve it. And 625 should be 5 to the 4th power, I believe. Yes, and then 5, same basis, so top should be same as well. So x plus 3 should be equal to 4. So minus 3, so x should be equal to 1. So that's my answer. So let me show you those. So to solve them, again, same thing. So x, my base, right? So x to the power 3 equals 8 over 27. So like, which number to the 3rd power is 8 over 27? So you can just say it maybe, but the official way should be, if we take to the exponent 1/3 power, we're gonna do this, like 3 times 1/3, they're gonna just cancel each other. It's going to be x, and here 8 over 27 to the power 1/3. You can just go to calculator and see the answer, and it's gonna work out. It should be like 2 over 3, I believe, yeah. Okay. And on this one, and b, should be what? Same thing. Logarithmic base 4x equals 5 over 2. I'm going to do this like 4 power 5 over 2 equals x. Oh, super cool. Just evaluate this and see the answer. You can go to calculator and see the answer, or you can go this way. 4 was 2 square to the 5 over 2. And as you've seen, 2 exponent means multiply them. 2 times 5. 10 divided by 2 is 5. 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2. It's going to be 32. X equals 32. That's my answer. And here, make sure guys you stop and try those examples, and then let's see what you got. And also guys, like again, like this is the same thing, like for logarithmic function, there are a couple of rules, but I don't go this way. I just want to provide you anyway. I go to Desmos, graph, and see the features of this function, like see the main range, increasing, decreasing. You can see everything there. If you want to go with formula way, that's the way to go. So graph each function, give the main range. I'm not gonna do all, I'm gonna just do, let me just do A, and then you can try B and C. So my function is, let me try A. Logarithmic base 2x minus 1. Let's go to Desmos first. F of x equals to, we go to functions, we gotta find the logarithmic stuff, not here, hopefully it's here. If you look at it, base is 2, inside was x minus 1, right? Yes, so let me, here we go. That's my function, right? Let me just make it smaller. Here we are. So we got the function domain and range. So domain and range. Again, I'm trying to do A. This is A. So this is logarithmic base 2x minus 1 function. So as you see, let's do the range first, which is y numbers, right? Like, it's gonna hit all negative numbers, it's gonna hit all those positive numbers, so we're gonna say all real numbers, or we can say like this way. But for domain, there's a restriction. Now on the Desmos, if you zoom in, I believe this one should be a 1. Like this graph has been getting super close to 1, but it won't touch there. So like my domain is gonna start from here. Like it's gonna go like this. there's no way to include the other part, other side. So I'm going to start with 1, and it's going to go all over to infinity, positive infinity. But there's no way for this graph to touch 1. But you can see that clearly on the Desmos. Just zoom in, you will see it better. And here, just use Desmos and match the function with its graph from choice A to F. Graph each and see it corresponds to which graph. So at this point, the last part of this lesson is there are some logarithmic properties. So you have to know those. If you see multiply, which means you can that's how you write them. That's how you expand them. If you see quotient property, if you see they are divided, that's how you separate them. If there's a exponent top there, it goes to the front, and you just write the rest same, and so on. Make sure to have a look at those values. Make sure you try to learn them. We're going to need them. Let's say have a look at first example. Let's say look at the first one. 7 times 9, right? So it's multiplied. So it's look like this first property, right? 7 and 9. So we can separate them with plus, right? So A should be what? It should be logarithmic base 6, 7 plus logarithmic base 6 and 9. And that's all. Use property to rewrite expression. That's how you extend it, and that's your answer for A. Alright? Have a look at B here. So B should be what? It's divided by, so it's look like this one, right? So we're gonna separate them by minus. So it should be what? Logarithmic base 9, 15 minus logarithmic base 9, 7. That's all what I do here. And lastly, let me try to show you C. Okay, answer C, let me go here. Logarithmic 5, square root of 8 means A to the 1/2 power. But that's why I'm gonna put here A to 1/2 power. So this one gotta remind you the third formula. If you see exponent, it goes to the very beginning. It goes here, right? As you see. And this 1/2 will come to front. It's gonna come to here and write the rest same. So logarithmic base 5, 8. Right? We are not solving them, we are not evaluating them, we are not doing anything. We just rewrite them, we just expand them. Alright, that's how we do it. And then let me show you this one as well here. So this one should be what? So this one should be logarithmic base A and 2 to the 3rd power. This 2 is keep here, this 3 comes under 2. Oh, if I got this one as exponent, that's a third rule, exponent property. But this 2 to the 3rd goes to front, and the rest should be same. That's my answer here. I'm not gonna do F here, it's gonna take so long, but let's show you E here. Okay, so we're gonna do this. Okay, but let me copy paste this. It's going to be a little bit longer. Okay, so as you see now, first don't see the bottom part, just look at the top part, m times n times q, right? So if we see times, we add them, right? So top part should be what? Logarithmic base A n plus logarithmic base A n plus logarithmic base A and q. Right? That's the top part, am I right? That's the top part. And then divided by those, right? Divided by means should be minus, right? That's the top part, right? And then minus logarithmic p square, right? Base A minus logarithmic base A to the 4th power. And lastly, I'm going to get the same logarithmic am, logarithmic an, logarithmic base a q minus this 2 comes to front, 2 log a p minus this 4 comes to front, logarithmic a t. Yeah? And that's how I extend this one. This is kind of crazy, but you won't see this on the assignment, don't worry. That's kind of a hard one, but just have a try, have a try. And then guys, I want to have a try those examples. So this time we're gonna go backward. Like this time we are given extended form. We're gonna write them as a single logarithmic. Like I want to see that like there's a plus here, so it gotta remind us like multiplication. There's a minus here that gotta remind us division. They all have same basis, logarithmic base 3. So this 2 should be times and then divided by 2. So x plus 2 times x divided by 2. So that's how I convert to single logarithm, and we can do it like this. On B, like since we have those numbers, we gotta put them back, right, as the exponent up there. So it should be what? Logarithmic a m to the second power, right, minus logarithmic base a m to the third power. So as of right now, there is a like subtraction here, which means we should divide them. So it should be m squared divided by n to the third power. So as you see, that's how I write them as a single logarithmic. And last, I have done already. And then have a try those, and that's all what we do on this lesson. And thank you for listening. Have a good one.